Now, class, I need to revise one thing. When I integrate xn dx, okay, is equivalent to xn plus 1 over n plus 1, then plus z. Correct? This is the power rule. When I increase the power by 1, okay, then I also divide by the increased power, then I plus c. Correct? And for integration, it's just like differentiation. We'll integrate them term by term. Everybody okay? Alright, now, example 5, can I keep example 5 to be the last example today? Because this one is the reverse, I want you to know how to do it properly. Okay, can I move on to the next part first? Okay. Now, what if I have this? That means I have integration of this. Now, it's the same thing. All of you look up, please. Don't copy. I will have ax plus b. Then I increase power, right? Then I must divide by the increased power. Then when I differentiate inside, I will get a, right? Correct? Ax plus b, because I am differentiating with, integrating with respect to x. So it will be this. That means you divide by the increased power, you also divide by the differentiation of the inside. Okay? Then c is a constant. Okay? So it's basically the same, just that when you have an expression, a linear expression inside, you must divide by the differential. Okay, I will show you an example. You don't have to worry. So I'll keep example 5 first. I will move on to example 6. Okay, now all of you look up. And don't tell me I want to do binomial theorem. Expand up, then I differentiate. I think it will fail. Understand? Okay, so all of you look up. First thing, I will increase 4 to what? 5. Very good. So I will divide by 5. Now don't forget, I must differentiate here. What is it when I differentiate? Negative 3. Then I plus c. Okay? So this will be a 2 minus 3x5 over negative 15 plus c. Everybody okay? Can understand? I think it's quite easy to understand this one. Okay? Now, next one, we move on to the next example. Now, this one, of course, cannot do first. Okay? I got to rewrite this first. What will this become? Negative 4, right? If I rewrite. Okay. If I increase this one by 1, I will have negative 3, right? Because negative 4 plus 1 is negative 3. So I will divide by negative 3, right? Times what? 3. Because when I differentiate, I get 3. Okay? So plus c. So the final answer now, can you see that this is actually can bring to the bottom? So I'll have 1 over negative 9. Okay? So this will be my answer to part B. Are we okay so far? Are we okay so far? Okay? So basically, can you see that these two rules actually don't contradict each other, but just that we got an extra one which is like that. Everybody okay? Everybody okay? Alright, good. Now next one. Next example. What if I integrate 1 over square root 7 minus 5x dx? Of course, I have to what? Rewrite. Agree? I have to rewrite. Integrate 7 minus 5x. Now, what's the power? If I rewrite. Negative half. Very good. Negative half x. Right? When I integrate this, I'll get 7 minus 5x. I plus 1. So it positive like that now. Now, do you agree that below become negative 5 over 2? So when I divide right, actually 2 times is negative 2 over 5, right? Okay, so this is negative 2 over 5. Now, this one can put to the top. 7 minus 5x plus c, like that, right? It looks very terrible. This one must put nicely, okay? Understand? Okay now. So, what does it mean? You have to increase the power, divide by the increased power, okay? But also must remember to divide by the differential inside that bracket. Then you plus c. Are we okay so far? Are we okay so far? Yes, okay. Now, what are integrals commonly used to find? Can you look at page 100? Integrals are commonly used to solve problems involving equation of curve, rate of change, area, most importantly is area, okay? Displacement, velocity, and acceleration, okay? Now, I will just do example 7 and example 8 first, so that you will know what I'm talking about. What I mean by integration, okay? Alright, so I will take away this already. Okay, let us read through this example 7 now. All of you listen carefully. The gradient of a curve at any point xy is given by this. dy dx is x squared x minus 2. This is dy dx, not y. Can you see? It's already the differentiation. You understand? The first derivative. Okay. The curve passes through the point. The curve passes through the point 2, negative 5. Find the equation of the curve. Okay. Now all of you look up. Do you agree this is the gradient function? That means this is dy dx, right? When I integrate this, I will get y, right? Do you agree? Dy dx, when I integrate this, I will get y, right? Alright? So y will be the same as the integration of this. Agree? Correct. When you differentiate, you get this bar. So when I integrate this, I'll get back, right? The curve. Okay. Now, I don't want this. I want like this. Easier to integrate. Can see? Can see? Okay. So I integrate this. What do I get? 2 plus x1. x4 over 4 minus 3 what? X cubed over 3 plus c, right? There's a constant c there. Now, of course, x4 over 4 is x4 over 4 lah. For some people do x2 until a long time, they don't know 3 over 3 is 1 now. Actually, this can be simplified. So it's negative 1. X cubed plus c, right? That means I have the equation. Alright. What must I find in order for the equation to be complete? C, right? The constant c. Okay. They say the curve passed through this point, right? What does it mean? When x is 2, what is my y? Negative 5. That means I sub in. Negative 5 equals to 2 to the power 4. Alright. So, negative 5 equals to, now this is 16. 16 over 4 is 4, right? 4 minus 8 is what? Negative 4 equals to c, right? Like that, right? Okay, so c will be negative 1, right? Okay, so what's the equation of the curve? Y equals to x4 over 4 minus x cubed minus 1. Okay? That will be the equation of the curve. Can you see what I'm talking about? Okay, now class, then let me ask you a question. What if they give you the second derivative? How would you find y? You must integrate how many times? 2 times. First time you integrate, you get what? Y dx. Then you integrate again, then you will get y. You understand what I'm talking about here? So, can you see it's just the reverse process? Are you okay with this example? Okay, good. Next, we will move on to example 8. Exactly what I was saying. minus 16 has 2 points, 0, 3 and negative 1, 0 on it. Find the equation of the curve. Now, if we have the points on it, that means the points must lie on the curve, right? Do you agree with what I'm saying? The points must lie on the curve. Okay, all of you look up here. This is d2y dx squared. When I integrate, I'll get dy dx. Alright? So, dy dx will be the integration of 6x minus 16, right? So, I will get what? 6x squared over 2 minus 16 x, right? Plus c, correct? Yes or no? Now, they give you 2 points. You choose one of the points first. Any point also can, you choose the other one also can, doesn't matter. Everybody okay? Haven't yet, haven't yet. Are you okay with this first? Okay, plus c, wait. My mistake, haven't. Up to here first. Because I haven't get y, you still divide the x. Okay? Can? Can or not? Okay, okay. Now, from here, I'm simplifying. 3x squared minus 16x plus c, right? C is a what? Constant. That means it's a number. Okay? Now, from dy dx, how will I get y? When I integrate this, I'll get y, right? That means I must integrate this guy, right? So I will have what? Alright. Everybody okay? So, what do I get here? 3x cubed over 3 minus 16x squared over 2 plus what? Cx, right? Constant of x. Then I must plus a d, right? Because there's another constant. Agree? Now, the constant, you use c, you use d. I told you don't use e. Straight away jump to f. Because e is a special number. Okay? Now, so I will have a x cubed minus 8x squared plus cx plus d, right? Okay? Now, do you agree that this one will be the equation of my curve? Okay? Just not make a mistake. And this curve passes through these 2 points, right? Okay? First of all, when x is 0, y is 3, right? This point. So I'll have 3 equals to d. Straight away, you can see it. Because 0, 0, 0. So d is 3. Okay? How about when x equals to negative 1? What is my y? 0, right? Can you see the other point? So when this is 0, I will have negative 1 cubed, negative 8 minus 1 square, plus c, negative 1, plus 3. Because d I already found out is 3. Understand what I'm talking about here? Okay, so this will be 0 equals to negative 1, negative 8 minus c plus 3. C will be negative 9 plus 3, so it's negative 6. Can you see? So what's the equation? Y equals to x cubed minus 8x squared minus 6x plus 3. Can? Okay, now, I need to tell you this, because they have given you very nice number. Can you see this is 0, this is 0? Okay? If they given you 2 points that is not 0, most likely you'll get a simultaneous equation in C and D. Then you have to solve the simultaneous equation. Are you clear? Linear simultaneous equation. So you either take equation 1 minus equation 2, then use elimination or substitution after. Okay? Understand? But because it's a kind question, they give you 0, you can give it over straight away. Everybody clear with what I'm saying? Okay, so sometimes, remember, this one might end up with a simultaneous equation. Are we okay so far? Are we okay so far? Okay, good. So that will be your example 8. Okay? As I've said, I want to move on to example 5. Turn back to example 5. And example 5 is very popular in O-level context, but not in this easy context. But I need to show you the easy one before I go on to the difficult ones. Okay? Alright. I want you to read through the question first. I'm going to teach you slowly, right? Let's take a look. Find this, part 1. Now, of course, this one means what? I must differentiate, right? Now, I find it very weird that when I have this in the exercises, some people go and use quotient. You square the bottom, after that you realize when you differentiate it is 0, then it's 0, that kind of thing. No need lah. Let me just show you. This is actually half times this one, right? You see? You see? This is actually what? Half 2x minus 1 half, right? You see? What rubbish? Alright, I'm differentiating this. Alright? Everybody okay? I'm differentiating this, right? Alright, so when I differentiate this half remains, right? Then times a half down, correct now? Then I will have 2x minus 1, right? Minus 1 is what become? Minus half. Then I times a 2, right? Because I've got to differentiate the inside. Now, can you see that when you differentiate your times, when you integrate, you must divide? Understand? Don't get confused in the exam. Okay, all of you look up, this is the important part. So, this will give me, can you see this one and this one cross off? It will give me 1 over 2 square root 2x minus 1. Everybody okay? Now, I'm going to write this final result over here. That means when I differentiate this fellow here, right, I will get, am I right to say that? When I differentiate this thing, I will get this thing, right? That means when I integrate this one, I will get back this one, right? Can you see the reverse order? Yes or no? Okay, so I've established this now. Okay, let's take a look at part 2. Hence or otherwise, find. Okay. I want to look at this. Can you see when I integrate this, then I will get this now. This one is similar, but there's one thing not there. What is it? The 2 at the bottom not there, right? Okay, now class. This is the original question. You cannot change the original question. You understand? But I must change it to similar to this, right? Then I can use that result now. Now, okay, all of you look up. Can you see I can put a 2 below? Then it will be the same, right? But if I put a 2 below, I must times a 2, right? Then it will cancel to be the original one, right? Can you see I cannot change the original? Okay, maybe I write in another step so that it doesn't confuse you with this step. I'll wait. This is the one that the question asked for. Do you agree that this one, when I integrate this, I must add a 2 here so that it becomes that one? Can you see these 2 and these 2 will cancel off? I'm not changing anything, no? I'm multiplying by 1, 2 over 2, no? 2 over 2 is 1, right? Can you see? Now, you can only multiply by a number, you cannot multiply by x. Only a constant. Understand? You cannot multiply by x because a lot of people make the mistake. They multiply x, multiply x squared is wrong. You can only multiply by a constant. So, do you agree that this is 2 times you integrate this? This is equivalent to 2 times the integration of this, right? Everybody okay? Everybody okay? So, it will become what? 2 times. I don't need to do already, right? Because this one by integrate is this one, correct? Then I plus what? I must plus c, because there's a constant. The b class. Okay, so I cancel this off. What's the final answer? Square root 2x minus 1 plus c. Everybody clear with what I'm saying? That means if they have this, and they have this. You must make sure it's the same, but you don't change the original expression. Okay? Now, what if they want this, which will never happen in real life now? What will this give me straight away? You know already. Can you see this is exactly this? So what will be the answer here? That's all. Can you see what I'm talking about? But because of this rubbish here, we got to multiply by 2. Do you get what I'm talking about? If not, I cannot make use of the previous result. Do you understand? Okay, now this is the simplest one. Because sometimes this will happen in partial part of the question. Then you got to move here and there. Then you got to get in trouble. You must know this very well first. Are we okay here? Are we okay here? Then what did I say? You can only add what? Constant. You cannot add variable. You cannot have x or y or whatever nonsense. Understand? It can only be numbers. Clear or not clear? Clear, huh? Okay, now, if you look at the textbook, right, they have used another method which I am not comfortable with the method. I want to change it to be the same. Then it's easier. Okay, this is how I do it because I always multiply by 1. 2 over 2 is 1, so that kind of thing. Everybody okay? Alright, huh? Okay, now, I am done with all the examples already, okay? What number is it on the AMAX content page now? Now I write what number? 15. Okay, now I write 15. Today's date is 6. Exercise 16.1. Integration. Okay? We are going to do it on full sketch paper. Okay, I'm going to write down number 4, number 5, number 6, number 9, number 12, number 14, 15, 17, 18. That's right. Okay. I want to do all this because I want you to know all the basics. Understand? I will guide you. If we do tomorrow, I'll see how much I can do today. Everybody okay? Cannot do, don't cry. You come back, I do for you. But please don't tell me do everything at my side. Because I don't want to, from now on, the homework become reset homework ever after. Okay? Alright, I want you just, what I chose 4A is because I want to test you, because when I do this, right, usually all of them will die in the exam. Okay, let's take a look at this. See whether you know the concept or not first. Integrate the following with respect to x. 4a. That means you integrate e squared with respect to x. All of you write this down. Now, you are integrating with respect to what? X. Now, everybody listen to me first. Don't do anything. Do you agree e is a number? E squared is still a number, right? Actually, this is a number, you know. It's a constant, yes. Correct, it's a constant. So what should the answer be? The constant x, right? Then plus c. A lot of people are confused. They go and put e3 over 3, you know. You are not integrating respect to e. You understand what I'm talking about? It's x and e is a number. You get what I mean? That's why this is very important. Everybody okay? Can so straight away done already, one part. Okay? Now, next. This one is also very simple. Must remember to write dx. If not, presentation will minus us. This one, if it comes out right, it's a gift from heaven. It will never come out. What is it? 1/3 what? X plus c. That's all. If I give you this right, you must thank me, you understand? For giving you 1 mark free of charge. Do you understand? If I give you this right, most likely some people will get it wrong. How many of you will think that you'll do e cube over 3? Be frank with me. I sure know that some people will do this now. That's precisely what last year's students done also. They will sure put e3 over 3, then they get it wrong. I said yes, please wake up. Understand? Now next. part C. Aha. Wow, something about use product rule. Please, integration got no product rule. Okay, I want you to realize something. What do you mean by 2x ln 3? 2 is a constant, right? Do you agree ln 3 is also a constant? Wait, I must write dx, I forget. Okay, now, I can rewrite this on top. That means I have a constant times x, right? Dx, right? Agree? Okay, so when I integrate, right, it will be the constant. What will happen to this? X squared over 2, right? What divided by half? Divided by the power, right? Then I must plus what? Plus C. Now, can you see that this thing cancel off? Alright, so this is actually x squared ln 3 plus C. Now, I want to know what's wrong with this presentation. Is there a difference? This one, if you write like that, right, people might think that it's like that. You understand? If you want to write like that, you must put like that. Then I know it's different. Do you understand what I'm talking about? You cannot anyhow write one. Understand what I'm saying here? Yes or no? Okay, Alright, good. That is your part C. Part D. I want you to think of what is 1 over pi. It's a constant. Very good. Now you can see already. Answer? 1 over pi x plus c. Or you can say x over pi is the same, right? Okay. Can you do E and F for me? I will go through this in about 3 minutes time. Why you only write birthday, you never write my WA? Huh? Same that, right? This is E max WA2, right? 26, right? Then this is what? A max WA2, right? Wow, okay, just remember birthday and never remember WA. That's very bad. Okay. Right. Okay. Can you tell me here what is a constant? 2e is a constant, right? Can you get an ex squared plus c? Okay. Hey, what I see, I never write this. Okay. Now I'm right. What is a constant? What is a constant? Ln 4. Okay. X what? X4 over 4 plus c, right? That means this is actually X4 over 4 ln 4 plus c, right? Usually I put the thing in front. Okay. Now, I want to ask KS one question. Chaos, can I do this? No, why not? Like what? IN, okay, IN. Is IN or LN? Whole class tell him IN or LN? He's angry with me. So IN or LN? LN, not IN. Please, I'm warning you because I'm going to circle everything again. Now, this one cannot cancel because this is not algebra. Do you understand what I'm talking about? So you just leave it. Now, what if someone write like this? Look up again. I'm telling you the different way. Like that can? Like that can? Probably no. Why cannot? I must cancel this first. I must not continue this. So it's kind of constant over constant. Then I x, then plus c, same. Agree? Don't you agree this is a constant? This is also a constant, right? If this is A and this is B, isn't this A over B? It's okay, what? Agree, class? Can? Understand what I'm saying, Okay, No problem? Hey, I'm talking to you, Any problem? Any problem? No problem, Okay, good. One more thing I want to warn the class, All of you. How to write this? LN. Don't write IN. Because the whole exercise will be wrong. Do you understand? Okay? Alright, good. Next question. Can we look at question number 5? Don't start first, we must do a simplification first, am I right? Okay? This one becomes what? First term. 2. Good. Plus 3x minus 2, right? If I change it. Correct? Actually it's 3 over x squared. Can you see? Okay, can you integrate this for me now? Okay. What's your answer? 2x, good. Plus 3x what? I plus 1, so become what? Negative 1 over? Negative 1 plus c. So how do I write it nicely? 2x minus 3 over x plus c. Yes, see or not? Okay. Alright, good. Next. Okay, I want you to simplify first. What is the first term? Now, if you cannot simplify like that, right? I tell you, you better write like this. Okay, it's the same thing, right? They share the denominator, right? Okay, what will this give me? The first term? What's the first term? Half. Good. Plus half what? X what? Negative 2. Okay, integrate for me now. from 2, when you integrate the constant is 2x. When you integrate x, I get 8x, right? So when you integrate 2, isn't it 2x? Turn your textbook. Okay. Alright. What is this answer? Can someone tell me? Half what? Half x, right? Then plus half x what? Minus 1 over minus 1, right? Correct now? Plus c. What's the final simplification? Half x minus 1 over 2x plus c. Now, I will need to warn you, this x is in the middle. That means it belongs to the top. This x is below. It's a different thing altogether. Is that clear? You cannot. Don't see carefully. Understand? Okay, good. So that is your number 5. Okay. 6a. What is your earliest WA that's coming? Is this the first one? No. That's what's this OE is what? Oh, oral exam. Is the O level? O like is the school one, right? Not the O one, right? Okay. So nobody has told you this one for what yet? So the earliest is actually mine. Not true also. Okay, never mind, whatever. Okay. I don't know what's happening in the school also. I only know my own WA now. But I know you're tired now. I do this last one, the rest you do yourself, okay? Alright, because I want to show you how to do this. Okay. How? Tell me. 3x plus 1 power what? 5. Divide by 5, then 3, right? No. 3, then plus c. So, over what? 15, yes, plus c. Can or cannot? Can or cannot? Okay. The rest you will do yourself. I give you the time now. Will that be okay? Alright, you shall stop the video.